Hello children, today we shall start with the last chapter of chemistry, and that is carbon. Now carbon is a very important element as far as study of chemistry goes. There is an entire branch of chemistry that is dedicated to carbon and its compound. So it's very important and essential for us to learn about carbon. Carbon occurs in combined states as well as in free states. So in free states we see it as diamond, graphite, coal, etc. Whereas in combined states it is present either in solid state like a lime, marble, etc. They are mostly metallic carbonates. In liquid state it is found as petroleum, and in gaseous state as carbon dioxide or carbon monoxide. Let's see some common compounds of carbon. The inorganic compounds of carbon are carbon monoxide, carbon dioxide, and all the metallic carbonates. Whereas the organic compounds containing carbon are methane, ethyl alcohol, citric acid, etc. The next thing that we need to learn is allotropy. So what is allotropy? It is the phenomena due to which an element exists in two or more forms in the same physical state with identical properties but with different physical properties. So when we see that one element is existing in more than one type of form, that is called a allotropy. So the tendency of an element to exist in two or more forms but in the same physical state is called as allotropy. We have crystalline and non-crystalline forms of allotropy. That is, they are the major allotrophies are crystalline and amorphous. Non-crystalline are also called as amorphous allotrophies. In today's video, we will try to cover the crystalline forms of carbon. So just let us have a look at the allotropic forms of carbon. Carbon consists of crystalline forms, which further consists of fullerenes, diamonds, and graphite. Whereas the amorphous form consists of charcoal, which is made up of sugar charcoal, bone charcoal, and wood charcoal. The next amorphous form is lamp black, the other being coke and carbon gas. So these are the different forms of carbon that are available on Earth. So what is the difference between a crystalline form and an amorphous form? If you see the picture on your screen, the crystalline form looks more symmetrical than the amorphous forms. So atoms vibrate in a place in a fixed pattern. So that is why they have typical geometrical patterns. And that's why they are crystalline in form. Whereas amorphous forms, they vibrate in various random arrangements and it is not a very symmetrical kind of a form. So now let's see the crystalline forms of carbon. The first one being diamond. The next is graphite and the third one is fullerenes. Fullerenes also consists of nanotubes. So diamond, it is the costliest gemstone and the hardest known substance. It is formed at a high temperature and pressure that exists about 100 kilometers below the Earth's surface. So how is a diamond formed? It is formed due to the high temperature and pressure below the Earth's surface. If you see the images, we can see basic shapes of diamond. Or why does diamond exist as a crystalline form? Carbons attached to other carbon atoms in tetrahedral bonds, giving geometrical patterns, and that is why diamond is crystalline in nature. Diamonds have a high refractive index. It has a very high melting point, that is 3930 degrees Celsius. It is a bad conductor of electricity. When ignited, it burns in air at 900 degrees Celsius and in oxygen at 700 degrees Celsius to give out carbon dioxide. We should know that diamond is nothing but carbon. So when carbon will react with oxygen, now diamond is a very strong substance, so it will take a high temperature for it to react with oxygen. So if it reacts with oxygen, if it is burnt in air at about 900 degrees Celsius or in oxygen at about 700 degrees Celsius, it will give out carbon dioxide. The next allotrophic form that we will see, that is a crystalline allotrophic form, is graphite. Graphite is lustrous, opaque and black. It is soft and slippery. It has a high melting point. It is insoluble in water and it conducts electricity. One very important property of graphite is it can conduct electricity, and that is why many times graphite is used as an electrode for process of electrolysis. It is opaque, black in color, it is shiny, it is soft and slippery and has a high melting point. So these are the important points of characteristics of graphite. The structure of graphite is as you can see on the screens. You can see different hexagonal shapes of carbon being attached to each other. So these are strong covalent bonds between carbon atoms. These form layers. Then the layer will have a weaker force of attraction with another layer, and that is why graphite is slippery. So one layer can slide over the other layer. So it can be cut very easily. Graphite is used in factories, battery storage, lubricants, crucibles, foundries, for pencils and other. So we see graphite has a wide range of use. Next is fullerenes and nanotubes. So this is the third crystalline form of carbon, and we nowadays see a lot of use of nanotubes in nanotechnology.